Okay, we have been doing a lot of videos and a lot of examples with graphing polynomial functions. And so far, whenever we graph our functions, we just make them nice, smooth, pretty curves. We cross through the x-axis every time. But what's up with this? Do we have to worry about that? Unfortunately, the answer is yes. That is what this entire video will focus on. That happens when you have an even multiplicity. Multiplicity is the number of times an x-intercept occurs. So if you factor it and it happens 2 or 3 times, the same factor shows up 2 or 3 times, that's when you have multiple multiplicities. I don't think I said that exactly right, but we will do some examples and you will get the idea. So if an x-intercept has an even multiplicity, if you have the same factor that occurs 2, 4, 6 times, then it's going to bounce off the x-axis like this. This is still an x-intercept, but it bounces off instead of crosses through. If you have an x-intercept with an odd multiplicity, 1, 3, 5, you know what odd numbers are, it's going to cross through just like normal. We're used to seeing factors only occur once, so we're used to them just crossing through, crossing through, crossing through like normal. It's the even numbers that are throwing you off this time. So let's do 2 full examples. We need to sketch a graph and we are going to have to deal with multiplicity. All right, sketch the graph of this long function here, polynomial, and I am going to give you the factored form. You could figure this out for yourself if you used long division, but that is not our focus in this video. Okay, so let's find our x-intercepts. You need to set each piece equal to 0. So negative x equals 0. I divide by negative, and we still end up with 0 isn't positive or negative. So x equals 0 is one of my x-intercepts. X plus 1 equals 0. Who cares about that squared right now? All we care about are just your basic numbers. Any place you see an x, set it equal to 0. So these are my 4 x-intercepts. All right, now let's talk about end behavior. I could look at the original standard form of my polynomial and find my degree and my leading coefficient, or you could look at the factored form. My leading coefficient is negative, which means the right-hand side points down. And my degree, you need to add up the exponents on your x's. Any x's that are in parentheses, use the exponents written right after the parentheses. If there isn't a parentheses, it's implied to be 1. So 1, 2, 3, 4, 5. So my degree here is 5, which is an odd number. Odd is opposite. So if the right-hand side points down, the left side points up. Okay, now let's talk about multiplicity. I know I kind of threw you off by talking about end behavior before multiplicity, but when we sketch a graph, we want to go through these steps and not deal with multiplicity until after we deal with end behavior. So let's talk about multiplicity. Okay, this x equals 0, there's a 1 here, so it has a multiplicity of 1. This x minus 1, there's a squared here, so it has a multiplicity of 2. This x equals negative 3 has a 1, so it has a multiplicity of 1. And this x plus 4 came from here, and it has a multiplicity of 1 as well. So there are none that have a cubed exponent. I didn't say this earlier, I should have. You use your exponents to figure out your multiplicities. And before we move on, I want to talk about what does it mean to have a multiplicity of 1. That means my graph, when I get to this x-intercept, my graph is just going to cross through the x-axis, just like normal. Same thing would happen here. It would just cross through if I had any with a multiplicity of 3 because they're odd numbers. This multiplicity of 2, 2 is an even number. You're looking at the multiplicity even versus odd, not the x-intercepts. This is an even number, so when I get to this x-intercept, I'm going to just bounce off of it instead of crossing through. All right, finally, let's figure out my y-intercept. I need to sub in a 0 in for all of my x's. You could do that here as well, which I may do just to make it clearer. when you type this in, you should get a 0 because one of my x-intercepts is 0. So my y-intercept is 0, 0. I have the x and y-intercept at the same spot. Okay, let's sketch it. Let's put all of this together. All right, we start by plotting my x-intercepts. So I have an x-intercept at 0, -1, -3, and -4. All right, let's do end behavior next. The right side points down, so the rightmost x-intercept needs to point down. The left side points up, so the leftmost x-intercept needs to point up. Now we're going to fill in all of our curves by using multiplicity. All right, so at -4, I need to just cross through. I'll go away from my x-axis before I come back to my next x-intercept. This should have been a -3. I have no clue where I got that 1 from. I think I was looking at the exponent and mixed it up. Super easy to do. I can understand why these confuse you because there's a lot of basic stuff to look at, but it's really easy to get mixed up. So, got confused for a minute. -3 is my x-intercept, which has a multiplicity of 1. Okay, so at -3, I'm going to cross through the x-axis. I'll go away and then come back to my next x-intercept. All right, -1 is where it bounces off. So instead of crossing through, I'm going to bounce off, go away from my x-axis, and come back down to my next x-intercept. And then at 0, it needs to cross through, which is good because when I cross through, I continue my arrow. So that looks really crazy. It's some kind of weird W extra shape. If you plot this on your graphing calculator, it'll look a lot smoother, and it may even go off of your axes because it probably goes way higher than what we did with these humps and bumps. But that is the general idea. My y-intercept isn't really helpful here because it's the same as my x-intercept, so it doesn't really confirm anything. Let's do another example. All right, we're going to sketch the graph of this polynomial, and I gave you the factored form again. So let's find our x-intercepts. It's factored already for us, so I need to set each piece equal to 0. Wait a minute. How do I solve this for x if there's not an x? That means there's not an x-intercept there, so don't worry about it. The 6, it tells us how to do a vertical stretch, which we don't care about while we're graphing these. So the 6 isn't really that much useful information when graphing this type of problem. Okay, so we only have 2 x-intercepts here. Because there's not an x with that 6, the 6 is not an x-intercept. All right, end behavior. I am going to look here. Everywhere you have an x, you need to add the exponents together to get your degree and use the sign of this coefficient to be the sign of your leading coefficient. You could also look at this. All right, it's positive leading coefficient, so it's going to end up pointing right. The degree is 5, which is an odd number, so they point in opposite direction, so it's going to point down on the left-hand side. And then let's talk about multiplicity. Zeros of multiplicity 1. 0 is another name for x-intercept. So I only have 2 x-intercepts here. X equals 1 has a cubed with it, so that means it has multiplicity 3. X equals -2 has a squared with it, so that means it has multiplicity 2. And there are none that have multiplicity 1. And let's talk about what this means. If it has an odd multiplicity, it's going to cross through your graph, cross through your x-axis just like normal, nothing weird. If it's an even multiplicity, that's the problem, child. That is where you bounce off. And then now let's find our y-intercepts. You can plug in a 0 for your x's in either the standard form or the factored form. I'm going to do factored form in my calculator because you will be using factored form on your homework, and I want to make sure that you feel comfortable typing that in. And you get -24. I can also confirm when I type it in, I'm going to end up with -24 because that is my constant term. And finally, we're ready to sketch this. So we start by plotting our x-intercepts. Now our end behavior. The rightmost side points up, the leftmost side points down. Now connect your dots using multiplicity. So from -2, I'm going to bounce off of the x-axis, go away, and then come back. And then at 1, I'm going to cross through the x-axis and continue my arrow, which is good. I can double check that my y-intercept is a negative number, and we had a negative number here. So that confirms that we are on the right track.